Hey guys, how are you guys doing? Guys ready for a full week of VPNs? Hey David, how are you? Yeah, you're all muted. So questions on the chat, feel free to ask. Because if I let the voice go, it's just too many people talking. So this is the best way I've basically discovered to teach it with a lot of people in there. All right, guys. So let me just share my screen and tell you guys what you guys are going to be doing this whole week. Where is the share screen part? You should be seeing my screen right now. We're going to be taking a look at a whole bunch of different iOS-based VPNs. This class is going to take you from scratch, means you don't need to know anything about VPNs. I'm going to start you off over there, take you all the way up until Flex VPN. We'll be taking a look at IPSec from scratch, take a look at GRE VPNs, GRE with IPSec, both tunnel as well as transport mode. You'll actually understand the difference between them. We'll also take a look at tunnel-based IPSec VPNs, which is also known as static virtual tunnel interfaces or SVTIs. Once we're done with the basic VPNs, we'll jump into your advanced VPNs. We'll take a look at MGRE, DMVPN, GetVPN with redundancy. Even with DMVPN, we'll do redundancy. We'll basically do a dual hub. VRF Lite, VRF Aware, IPSec VPNs, IKE V2, and Flex VPN. It's a very valuable class. This is basically, I would say 90% of what I would actually do in my CCIE security bootcamp for the VPN section. And the good part is I'm going to start it from scratch and take you all the way up until the CCIE part in terms of VPNs. Good. In terms of timings and stuff, I'm going to do it based on, I'm going to set the time based on your Pacific Standard Time. The timing of the class is going to start at 9 o'clock in the morning, Pacific Standard Time. And it'll go from 3 to 4 hours, depending on each day. The class will be from Monday to Friday. And hopefully we should be able to knock out all these different type of VPNs by the end of the week. You stay with me. I'm going to make sure you guys know VPNs by the end of the week. Good? Everybody okay with this? Any questions that you guys have, please feel free to put them on the chat. I am looking at the chat, so I'll answer them as the questions come through. All right, now in terms of my environment that I'm going to be working off of for doing the labs, it is a complete hands-on type of environment. The things that you see over here on the screen, all of them, I'm going to lab them up and show it to them. But before I take a look at the lab, I'll actually explain to you guys the technology behind it. And any command that I type in, you will actually know what the purpose of that command is. So when you're doing a VPN configuration, you'll understand what each command is doing. And if you don't put the command in, what are the implications of that command missing from your config? So you're not just going to do a copy-paste, copycat type of thing for your VPNs. You'll actually understand what you're doing with them. In terms of the environments, the labbing that I'm going to be doing is I'm going to be doing it on IOU, because I'm doing it strictly based on routers. I'm not doing any VPNs over here based on firewalls. It's just Cisco routers. In terms of IOU, the environment probably will take you about 2 gigs of memory on a laptop to be able to run it. Well, 2 gigs for IOU. I would recommend an 8 gig laptop minimum to be able to do all these different labs that you have. Besides the labs, whatever I do in terms of notes, I will send that out to Katie from RouterGods. She will make the video of this and the notes and the diagrams available to you guys through RouterGods. All right. So this class is getting recorded. Just put it in the chat. I'm looking at the chat, Kenny. All right. So with that in mind, let me show you. Yeah, I'm recording it myself, and I'm going to give it to Katie at RouterGods to upload it. You can see that again if you go to the participants. I don't know if you guys see that on your side against my name. There's a small little button that says recording, or that has a recording symbol on it. Basically, it's telling you that this whole class, my screen, the voice, everything is getting recorded. In terms of the connection, should not have any problems with it, right? The voice is clear, the screen is clear at this point. All right, good. So with that in mind, the first thing that I want to talk about is IPSec. What does IPSec bring to the table? Why do I want to do it? But before we get into IPSec, I want to talk about a concept of VPNs. What is a VPN? And that's where a lot of people get confused. A lot of people think about a VPN as a secure mechanism. In reality, a VPN by itself does not need to be secure. A VPN is basically connecting two private networks. So you have a private network on one side. I have another private network on one side. Basically, two sites belonging to a company generally. They want to connect up to each other, but they don't have the infrastructure in the middle. So both sides connect up, let's say, to the ISP or a service provider, and the service provider connects them up virtually to each other over the service provider cloud. So service provider owns this network, which is connecting this private network over here on the left to this private network over here on the right. When I connect these two private networks to each other over a public network, that mechanism is known as a virtual private network. Now, to connect the private to private over a public network does not require encryption. How many people have heard about a technology by the name of frame relay, or Q&Q tunneling, or MPLS VPN? All these are forms of VPNs, but none of them provide any level of encryption. They're all VPNs. Frame relay allows you the ability, which is a layer 2 technology, allows you the ability to connect this private network to this private network over the service provider cloud. It does it based on a special number that the frame relay cloud uses. It assigns every site a number known as the data link connection identifier, or the DLC number. The public network over here is the service provider frame relay network. The private network belongs to the company. I'm connecting the two private networks to each other. Logically speaking, virtually speaking, these two private networks assume or look as if they're directly connected to each other. If you worked on frame relay, you would have given this IP address. This would look like this: .1 and .2. So they're connected to each other over this public network as if they're directly connected. These are two private networks. That is a VPN. When you're doing it where the service provider is forwarding the traffic over here based on some type of technology, for example, it's a layer 2 technology, this type of VPN is known as a layer 2 VPN. Do you get my point? So that concept or misconception that people have that anytime you use the word VPN, it means encryption is wrong. VPN does not automatically mean it is secure. It is recommended to secure it because you're going over a public network, but the requirement is not to secure it. The requirement is to connect a private network to another private network over a public network. Everybody okay with that? Yeah? Now, another common misconception, and this is something that I've faced personally, is another type of VPN that is forwarding the traffic over here on the service provider cloud based on a technology known as labeling, MPLS. And I'm connecting a private network over here to a private network over here, where the forwarding of the traffic in the cloud is done based on what? A label. Label switching. So when a service provider provides MPLS capabilities to connect a private network to another private network over what? The service provider network, that's the service it's providing. It calls this an MPLS VPN, a label switched VPN, because the forwarding in the core in the cloud is done based on labels. Is that secure? Is MPLS secure? Is it encrypted? No, it's not. It's segregated from the other clients of the service provider. So if this is customer A over here that I'm connecting, its traffic will be segregated from the traffic of customer B. But it doesn't mean that the service provider, if they want to, they cannot sniff the data and see what you're transmitting from one private to the other. So it's still clear text. So MPLS VPN is, again, not a secure mechanism. It is just a segregation mechanism in which the service provider segregates the traffic of one customer from another customer. Everybody okay with that? You understand that? Again, this is known as a MPLS VPN, because the forwarding over here is done based on a label, which is between layer 2 and layer 3, so it sits in the middle. Good so far? Now, we're not going to talk about any of these type of VPNs. Our focus is going to be on a layer 3 VPN, where the forwarding of the traffic in the cloud is not done based on what? Layer 2 technologies or label switching. What I'm going to be doing in this technology is taking a packet which is an IP packet over here, and running it through another IP packet. So the forwarding over here is going to be done based on a layer 3 header. These type of VPNs are known as layer 3 VPNs, where the forwarding is done by encapsulating an IP packet into another IP packet. For example, let's say this is the internet over here. This is the service provider. I have a private network over here, let's say 10.1.1.0, and it wants to communicate to my other site, which has an IP address of 10.2.2.0. Two sites belong to the same customer. I want them to communicate to each other. Can I send this packet over the internet in the form that you guys see as? So if I wanted to communicate from the left to the right, can I send the packet as 10.1.1.1 going towards 10.2.2.2? Is it possible to route the packet on the internet? The answer is no, because these addresses are RFC 1918 addresses. These are private addresses, correct? So what you do is, on the edge router over here, and on the edge router over here, who would have some public addresses assigned to them, they would take the packet from 10.1 and 10.2. They would create a VPN which would say anything that's coming in from 10.1 going towards 10.2, I want you to encapsulate that IP packet into another IP header where I would have the public address. Let's say the public address over here is 199.1.1.1, and the public address over here is 200.1.1.1. So I'm going to configure this router over here to take the packet that is coming from 10.1.1 going towards 10.2.2. I'm going to configure the router to add a new header, an outer header, which will be from this source, and I know that 10.2 has a public address of that. And I'm going to forward this packet over the internet, where the forwarding is going to be done based on my outer header, which is again a layer 3 header. So the forwarding is based on layer 3, which are public addresses. So basically what I'm doing is an IP packet. I'm taking an IP packet, putting it inside an outer header, another IP packet. This is known as a layer 3 VPN. Good so far? And that's the VPN that we'll be focusing on in this particular class. Now let me ask you this. When I'm doing this, IP and IP, is it required that I encrypt? Required. No, just like I said, a VPN does not require encryption. I don't need to encrypt it. As long as I encapsulate it, it might be clear text, but I would still be able to forward the traffic over the internet. Okay, a typical example of this is if I ran this using a protocol called GRE, which we'll be taking a look at over here, that would allow me the ability to do this, but GRE in itself will not allow me to encrypt it. So it would be clear text traffic going across. Is it a best practice? Absolutely not, because I'm going over the internet. I don't want my traffic to go in the clear. That means somebody on the internet can actually look at my data. Right? But what I want you guys to understand, there's a difference between what is required and recommended. I don't want you guys to go out and say, hey, listen, encryption is a requirement of a VPN. That's wrong. Yeah, it's absolutely recommended, but it's not required. You get my point? All right, good. So the type of VPNs that we are going to take a look at over here are your L3 VPNs. In here, with L3 VPNs, we will be exploring two main protocols that provide you the capability of doing L3 VPNs. The two protocols that we'll be taking a look at, predominantly IPSec, and in some instances, GRE, or a flavor of GRE. So my layer 3 VPNs, I'm going to implement using either the IPSec protocol suite or the GRE protocol. Absolutely correct. Absolutely correct. It just segregates your traffic. It does not encrypt. So if you run a sniffer on a VRF-based traffic, you'll see it's encrypted. It's clear text. It's not encrypted. Good so far? All right. So this is my objective. So just want to make sure everybody is on the same page in terms of what we'll be doing, what we'll be covering. So these type of VPNs that I listed over here, the ones that we'll be going over here are either going to be IPSec based or GRE based. And I'll point them out as we go through what are they doing. You also have a small section over here for VRFs. So we'll also take a look at that as well. All right. Take a look at these in terms of the VPNs that we're going through. Step back for a couple of minutes, take a look at it and see if you have any comments or if you want to add something to it, have any questions about them. And then we'll get started with IPSec overview. Again, as I said, it's going to be going through the entire week to be able to cover this. So we'll do a whole week of this. It won't be done in one day. But I'll promise you at the end of the week, you will be much better off in terms of VPNs. The good thing about this is it's not only covering if you're planning on taking your CCIE exam, this prepares you for the VPN section on Route Switch, because Route Switch has a big section, significant section on DMVPN, and the rest of it not just the rest of it, the entire thing is relevant from CCIE security. MPLS would not be a layer 2 VPN, Kenny. The reason is MPLS actually operates between layer 3 and layer 2. So what they do is, let's say you take a look at your OSI reference model, you have the physical layer over here, 2.5, and that's what they call it actually. So after that, you have your layer 2 where your MAC address or whatever your layer 2 header is resides at. I would just say layer 2 header. If it's Ethernet, it's going to be the MAC address. If it's frame relay, it's going to be Delci. Now, then you have a layer 3 header, which is over here, which is your IP header. The actual label switching takes place over here based on the label, that 32-bit label that you have. It's called 2.5. So when you talk about MPLS, that's why you refer to it as an MPLS VPN. So you would have a layer 2 VPN, you would have a layer 3 VPN, and then you have an MPLS VPN. Get my point? That's why it's called MPLS VPN. VPLS is layer 2. Q&Q tunneling is layer 2. IOU. Because my focus over here is predominantly on router-based VPNs. I don't need firewalls or anything like that, so IOU is good enough for this. You have EVE-NG that you can do the same thing on, but it's a bigger virtualized environment. So this is easier to implement on lower-end laptops as well. That's why I chose IOU for the demonstrations. Good? Now, let's go ahead and take a look at a small primer on encryption. That would give you an insight of how IPSec works. Okay? Based on that, your understanding, your foundation of how IPSec needs to be configured will be a little better. It'll make you more comfortable in the commands that you're typing in, more understanding of the commands that you're typing in, and why would you type in commands after you go through this. Now, what is encryption? Encryption, as I said, VPN only allows me the ability to do what? Allows me to connect one private to the other private by putting a outer header on it, but the traffic that's going through it is clear text. But if I want to secure it, I want to scramble it so the person in the middle does not see it. That's what encryption is all about. It's basically doing what? Scrambling the data in transit so the person in the middle cannot see the data. In order to do scrambling, in order to do encryption, I'll give you a very simple example, the most primitive example of doing encryption. All right? Let's say entity A wants to communicate to entity B. They talk to each other. They come up with an encryption scheme that will allow me to scramble the data. What they do is they talk to each other, then they agree upon this. They say, if I send you the letter, if I send you the number 1, it corresponds to the letter A. If I send you the number 2, it corresponds to the letter B. C is 3, D is 4, E is 5, and F is 6. Guess what? If B wants to understand that, B also needs to have what? The same characteristics on the other side. I'm just giving you half of it. It would have it for each and every character that you need to send across in that list. All right. Now, once I have that, now both sides have it. Same. This is known as a key. This is an example of an encryption key. Okay. So if I want to send the word bad, I'm going to send what? 214. The guy in the middle, oh, it's just 214, it's some number that's going across. But when he receives it, what does he do? He decrypts it or reverse engineers it and sees what? 2 is B, 1 is A, 4 is D. Understood? Now, in real life, it's not as simple as this, but it gets the point across. You guys understand what I did? I encrypted and decrypted the traffic, whereas the guy in the middle is still under the impression that he's just sending some random number. Both sides have to have the same key, absolutely. If I'm encrypting, the other guy needs to know how to decrypt it. Good so far? And the key is an important part of that. It needs to match. Clear? Now, at the same time, the guys in the middle also figure this out, that they are doing some encryption. So what they start doing is they start gathering or collecting this data. This garbage. So the guys in the middle did what? They started collecting all this garbage that's going across. Why do they collect all the garbage? Once they collect this, what they do is they take the garbage or data that is scrambled and they run it through an attack known as the brute force dictionary attack. In which they will take the data and take one character at a time using a computer program. They will try to look at different combinations in which the characters that are appearing over and over again make sense with the word in the dictionary. So basically what's going to happen is when they have a lot of data, they can say, hey, listen, anytime the letter or the number 2 shows up, it corresponds to a valid word in the dictionary, and that word is, or the letter is B. Anytime I see the number A, it is corresponding with the different combinations that I have. It corresponds to the letter A. Anytime I see the number 4, I look at the different combinations, and that number 4 corresponds to the letter D. And if I change it to D, it makes sense because it matches a dictionary word that I have in my decryption program or the hacking program that I have. You guys understand that? And that attack is known as the brute force in the sense that I'm going to do it one character at a time, and I'm not doing it manually. The program is going to run it like a cycle of different algorithms to figure out if it matches the word in the dictionary, and based on that, it can reverse engineer and find out what the key is. And once it finds the key, what does it do? It runs the key against the collected data, and the entire data now is compromised. All right. So how do I break a key? What's the requirement of breaking a key? I need to collect what? So if I let a lot of, what do you call it? A lot of data get encrypted using the same key, what's going to happen then? Eventually, the guys in the middle will figure out, based on the brute force dictionary attack, they will be able to figure out the characters. And based on that, they'll be able to crack the key and crack the data. So how do I get around that then? If that's the case, how do I protect myself? Well, one of the ways to protecting myself is change this key on a frequent basis. Rotate the key or change the key. So this was a key for me for, let's say, 1 hour or 2 hours. And then what do? Have somebody go in and change the key. Understood? So now my A is, let's say, 51, B is 52, C is 53, and so on and so forth. So now it's going to throw off the algorithm in the middle. Now this key that I'm using to encrypt the data, if I have to change it on a regular basis, it becomes cumbersome, doesn't it? You need to have a person that goes and changes this key on a regular basis. So what they did was they said, well, this is too much of work to change the key on a regular basis. Let's write an algorithm that will generate this key for me on a regular basis. And that's where an algorithm came up that was there that is meant to do one thing and one thing only. What is that? To generate this key on a frequent basis so that a person doesn't need to do it. And that algorithm is known as the Diffie-Hellman algorithm. What's the job of Diffie-Hellman? The job of Diffie-Hellman is on a frequent basis, depends on how you configure it, the time that you configure it. As Ulf said, the lifetime that you configure. On that lifetime, Diffie-Hellman will go ahead and generate a key, a dynamic key. This key will be valid for a certain amount of time. By default on a Cisco router, the lifetime of this Diffie-Hellman key is 3,600 seconds, which is basically 1 hour. So every 1 hour, a new dynamic key will be generated that will be used to transmit the data for 1 hour. And after 1 hour, what does Diffie-Hellman do? It will rotate this key, create a new key with a new set of values. Does that make sense? So what's the purpose of Diffie-Hellman? Generate a new key every one. Depends on your time. The default time is 3,600 seconds. Everybody okay with this? So this guy will do the same thing over here. But now they're generating this key before we had an agreement. The two administrators talked to each other and they said, hey, listen, this is my key. And the other guy said, this is my key. This key is generated independently by whom? By Diffie-Hellman. What do I need to do with this key so that the other guy knows about it? I need to send this key to whom? This guy, and this needs to send it to this guy. I'll talk about that in terms of the time. Are they done at the same time? I'll explain that when we go through it. Hang in there, that question will be answered. So I need to take the key that A generated and send it to B. So B knows that whatever information that will be sent by A will be encrypted by using this key. I need to have that key to do what? Decrypted. And my encryption key was generated by my Diffie-Hellman. I need to send that to him so he can decrypt. So what's the first thing that I need to do over here? Once the key is generated, I need to exchange the key with whom? With my peer, so he knows how to decrypt it. You guys understand that? Otherwise, whatever my key is, he does not know. What his key is, I don't know. Good so far? So in order to do that, now that first thing I did was I came up with a dynamic key generation mechanism so that I don't have my key compromised because of the collection of the data. But now the problem is I have my keys. I need to tell the other guy what my key is. So what they did was they came up with a mechanism of exchanging my Diffie-Hellman key. So A generates a Diffie-Hellman key, which is known as the session key. This is going to be valid for a particular session, which will last for 1 hour. This guy has his own session key generated by his Diffie-Hellman mechanism. I need to exchange the key. So they had to come up with a mechanism of taking the session key and sending it across to whom? To the other guy in a secure manner. So what they did was, before the data encryption took place, they came up with a mechanism in which they would set up a secure tunnel, which will not exchange any data. Instead, the job of the secure tunnel is going to be to secure what? Securely transmit the session key from A to B and B to A. Understood? So before I can do any data encryption, I need to have the session keys exchanged. So I set up a tunnel just for the purpose of doing what? Exchanging my session key. That was done by using a protocol called IPSec. So the purpose of this tunnel, called the IPSec tunnel, is just to exchange what? The session key. No data will be transmitted in the IPSec tunnel. Just the session key will be transmitted across in that tunnel. Good so far? But the question is, how do I secure this tunnel? Because if I don't secure this tunnel, my key is going across in clear text. Correct? No, hashing doesn't secure it. Hashing just makes sure that it's not tampered with. Good. This is just the beginning. So now, to set up this tunnel, I need 3 parameters. Any secure tunnel that I'm going to be establishing requires 3 parameters. I need a key. The key is like a start point. But in order to do the encryption, I need an encryption mechanism. The key will be used in conjunction with the encryption mechanism to be able to secure this session key. So to set this tunnel up, I need a key, which needs to be the same on both sides. I need an encryption mechanism. That is the actual algorithm to do the encryption. And the third thing that I need for a tunnel is what is known as a hash mechanism, making sure the key does not get changed. I need to define them where? On both sides manually so they match. So I am going to set one key over here manually called a pre-shared key. Pre-shared means what? Pre-shared means they have communicated to each other either through the phone, WhatsApp, Facebook, email, whatever mechanism, but they have told or talked to each other about keeping the same key. So an example of a key would be, let's say, Cisco 123. And the key over here is also what? Cisco 123. So they manually talk to each other, pre-share this key and say, hey, this is my key. And then they talk to each other and say, hey, listen, let's go ahead and use a encryption mechanism. There's different ones. There's triple DES, there's DES, there's triple DES, more secure, and there's AES, different flavors of it. These are my different encryption algorithms to encrypt or scramble the data. Whatever algorithm I choose on one side, let's say I chose this one, I need to match it where? On the other side. Is the pre-shared key only for the IPSec tunnel? Absolutely correct. It's just to secure the IPSec tunnel. Good. Now, what did I tell you? Now I'm sending the data. I don't want people to change the key in the middle. Okay. So I need to make sure I do an advanced algorithm for a checksum to make sure the transfer is not corrupted or changed. For that, I need a hash algorithm. The two main ones that you have for this are SHA or MD5. Again, whichever one you guys want to pick, you need to match it on both sides. Let's say the two administrators over here agree upon MD5, for example. So it has to be MD5. So these three parameters manually set on what? Both sides need to match. Based on these three parameters, this first tunnel will be set up. So now I'm ready to do what? Set this tunnel up to do what? Exchange my session key. Actually, now I'm ready to do what? Generate and exchange my session key. So at this time, Diffie-Hellman kicks in and does what? Generates a session key. The session key is the one that will be used for the encryption of what? Of data. That is your session key, dynamic key, whatever you want to call it. Also known as a traffic encryption key, because it's the one that's going to be encrypting your traffic. Got it? Now, when you generate the key, it's entirely up to you how sophisticated you want the key to be. Okay? If you have a more sophisticated key, means the algorithm will be more sophisticated. It'll take more time to encrypt. So the performance will take a hit. The easier the key, the smaller the key, it's easier to encrypt, faster to encrypt, but easier to break as well. Okay? So Diffie-Hellman gives you a choice. Hey, listen, what do you want to do? Do you want to do a small key or a large key? So generally, you'll get a choice between 768-bit key, which is called Diffie-Hellman Group 1. You get a choice of 1024, which is called Diffie-Hellman Group 2, which is like the key ID. And the third one, 1536, which is Group 5. So you set your Diffie-Hellman group. You need to match it on the other side. Whatever you set up on one side needs to be the same on the other side. So for example, if the two administrators on the two sides say, hey, I want to take the middle ground and I want to create a key that is secure but does not affect the performance too drastically. All right? So Diffie-Hellman will generate the key and exchange the key with each other. Good, everybody? So what is the actual transmission that takes place over here on this tunnel, the first tunnel? What's the only thing that's going across over here? Any data? Any of the actual data? No, 1536 is 5. So the only thing that goes across is the session key. In reality, I'm making it simple for you guys so you guys understand it. In reality, not even the entire session key is established or sent across. It's certain algorithmic numbers that are exchanged in that exchange. The actual key can easily be generated by the other side based on those start point numbers. All right? But from your perspective to understand it, just think about it, the exchange of the session key takes place. I don't even need to send the entire key across. I can send them certain parameters of the key generation algorithm. The other guy will know what to do with it. All right? But from an understanding perspective, think that this is used to do what? Exchange the session key. This is known as tunnel 1, phase 1, IPSec tunnel, all names for the same characteristic, same tunnel basically. Good so far, guys? Now let me make sure you understand that. What are the parameters that are required over here to set this first tunnel up now? Now that you guys know what I'm doing, what are the parameters that I need for setting this tunnel up, first tunnel up? On both sides, I need to set up what? A common key, a pre-shared key. I need to set up an encryption algorithm for the first tunnel. I need to set up a hash algorithm for a first tunnel, because all tunnels require a key, encryption, and a hash mechanism. And that needs to match where? On the other side. All right? What else do I need to specify? At this time, my tunnel is up. What was the purpose of the tunnel? The purpose of the tunnel was to encrypt my session key. So, right? Share the PSK. No, not the PSK. PSK is this. You manually would do that. Share the session key. But for that, I need to generate the session key, right? Each one will independently generate their own session keys, right? What I need to specify over here is the size of that session key. What do I mean by the size? Remember what I told you? When Diffie-Hellman generates a key for the encryption of the data, the session key, it will either be what? Group 1, Group 2, Group 5, right? PSK is to secure the first phase. This is your PSK, the pre-shared key. Got it? This is your key for what? The second tunnel. So whatever I chose as my mechanism, let's say I pick 1024, which is 2, I need to say group what? My Diffie-Hellman group is, let's say 2. And this guy needs to match what? The same group. And I need to manually ensure that these parameters are matched on the two ends to set up my first tunnel. Good so far? Have I encrypted any data at this point? No. What is the end result of this tunnel? What have I accomplished at the end of this tunnel? What has taken place at the end of this tunnel? The session key is exchanged, correct? The session key is exchanged. So right now, both sides have what? Session key, they're ready. What match identifies phase 1 is successful? What message? What mechanism identifies that phase 1 is successful? Mechanism meaning? For it to be successful, you'll see a message saying that it's successful. Set up. If you're looking for show commands, we'll do that. We'll do that. The show commands, I'll show you. Don't worry about the commands. I'm not doing the commands yet. I'm just telling you the parameters that are required. Those commands and stuff, I'll show you all of that. Now, over here, I have the session key ready. What did I tell you to set up a secure tunnel? What are the parameters that I need? What are the 3 parameters that are required to set up a secure tunnel? Help me out with that. What are the 3 parameters to set up a secure tunnel? Key, encryption, and hash, right? Right there. These 3. Out of those 3, what do I have right now? What was the end result of this? I have the session key generated. Right? What do I need for second tunnel now? What are the other parameters that I need for the second tunnel? I need an encryption and a hash mechanism. I'll do that, Chris. For 1 second, we'll finish this and I'll talk about that. So session key is there. I need what? Encryption and hash for what? My second tunnel. Independent of the first one. Maybe on the first tunnel, I might have used my parameters as, this is the pre-shared key, let's say Cisco 123. My encryption might have been triple des. My hash might have been SHA. When I go to my second one over here, I can use triple des, but for my hash, I might use MD5. As long as the other side matches. So just because I use SHA in tunnel 1, I don't need to use SHA for the second tunnel. These are 2 independent tunnels. So the parameters required to set the second tunnel up don't need to match the first one. Do you understand that? But they do need to match each other. So on the other side, my encryption in my hash needs to match the encryption in a hash over here. The session key is already exchanged through the first tunnel. So what parameters do I need to set up my second tunnel up over here? My encryption and hash, because I have my session key already generated in exchange by phase 1. Everybody okay with this? You understand that? That's absolutely right, Kenny. Absolutely right. Good. Now, that is also true, Marvin. Right now, what I want to do is I want to keep it simple. I'm just using a pre-shared key. There are 2 different mechanisms of securing the first tunnel. This key over here could be done either using a pre-shared key, or I can use certificates using a mechanism called public key infrastructure, or PKI. So I'm just using the simple one because my concentration is to make it simple on you guys for right now. Got it, Marvin? Now, let's go to the commands. If I want to set up a tunnel up, okay, I want to set up a tunnel up. The first thing that I need to do over here is configure the phase 1, which is also known as what? The IPSec tunnel parameters. Okay, what parameters do I need? I need a key, which is known as the pre-shared key, because the two entities will communicate to each other what they are. I need an encryption algorithm. Now, somebody asked me the difference between encryption versus hashing. Remember the thing that I told you, the A to B to D, all those type of things? A equals B, this guy, and I send bad as this. This scrambling of the data, changing of the data is called encryption. Yes, Fernandez, it is getting recorded. I will send the video to Katie at RouterGods and she'll make it available to you. Somebody had a question about encryption. Who was that? Do you understand what encryption is? Actual scrambling of the data is encryption. So what is hash then? So this is not hash. This absolutely is not hash. Hash basically makes sure when I get to 214, I do an advanced version of checksum against it. So I take the data, run it to a very advanced level of CRC, and I put a value over here. And like a mathematical result of that hash that I run. And I send the data across to the other side. And this hash that I do it based on my pre-shared key. So in order to get the same number, I need to have the pre-shared key as well. So when I get 214 over here, I'm going to take 214, use my pre-shared key, run the same algorithm over here, and what should I get? Same number. If I get the same number, what does that mean in the middle? That means nobody changed it. If they had changed any value over here, even a bit, this number would be off. And I would know that it's a wrong number. That mechanism of creating this checksum is known as hashing. So hash does not encrypt the data. It just makes sure the data is not tampered with. It maintains your data integrity. You good with that? You understand the difference between the encryption versus hash? Right? Now, what's the third thing? So let's say we agree upon triple des over here as my encryption mechanism for phase one. What's the other thing that I need for phase one? Hash. Let's use MD5 over here. So the mechanism of hashing I'm using is MD5. Done? So at this time, my secure tunnel is set up. What's the next parameter that I need? What was the purpose of this tunnel? To generate and exchange my session key. So the Diffie Hellman, that is your group. As I said, there's group what? 1, 2, or 5. I'll pick 2, middle ground. Good so far? And nowadays you have more advanced versions of it as well to create a more sophisticated key. This is it. This is all I need for what? My phase one. These 4 parameters. You want to take a look at the commands that you do on a Cisco router to do that? Crypto, ISACAM, policy, and you can have multiple policies because I can have tunnels with different entities. So I can create policy 1, policy 2, policy 3. Policy 1 might be from A to B. Policy 2 might be from A to B, A to C. Policy 3 might be from A to D. So it can have different policies for different entities. But right now, I just have one. So I'll just say policy 5, just a number, like a sequence number. In there, I'll specify my authentication is, I'm doing pre-share. I need to specify that. Why? Remember I told you can also do the authentication based on what? The certificates, PKI. If I was doing it through PKI, I would specify that. But right now, we're keeping it using what? Pre-shared keys. Pre-shared keys means I need to set the key manually. Let me set that up. So I'm going to set the key as Cisco 123 for the remote address. What is this address? When I communicate to YYYY, which is the public address on the other side, this is my key. So for this peer address, this is my key. Good so far? So that took care of one of the parameters. What are the other ones that I have? Encryption, hash, and what else? The group, right? For the Diffie Hellman. Dinesh, your question is just to me. Just change it to everyone so that everybody can see your question or your response. That's it. Those are the parameters that you need in phase one. Understood? Any question about any of the parameters that I specified over there? This is the first tunnel. This is your first tunnel. Good. Now, I need to do the second tunnel now. Configure phase 2. This is known as the IPSec tunnel. The protocol over here that is used is a protocol by the name of ESP. Lifetime, there's 2 types of lifetimes. There's a lifetime for this tunnel, which is generally 86,400 seconds, 24 hours. And there's a lifetime for this session key that is generated. That lifetime by default is 3,600 seconds. If you want to be more aggressive, you can cut that down. When you cut it down, that means it's a more secure tunnel. Now that depends on your particular environment, whether you want to change it or not. I'll show you how to change it, but whether you want to change it or not depends on your environment. Now, what do I need to do in phase 2? What was the end result of phase 1? I got my session key. What did I tell you that I need for my second tunnel? I need the 2 parameters. What are the 2 parameters that I need? The encryption and the hash for my second tunnel. That is done by using a command called crypto IPSec transform dash set. ESP, that's the protocol. Triple des is my encryption. ESP, let's use a different one over here. SHA HMAC, which is the variant of SHA that Cisco uses. So those are my encryption and hash parameters. I already have the key from where? From phase one. Why did I do phase one? Remind me. What was the purpose of doing phase one? Yeah, but why did I do it? No, not to share the PSK. To set the session key, set up the data encryption key. But why did I do it dynamically? Why didn't I do it statically? Because if I do it statically, I would need to rotate the key manually. And if I don't change the key on a regular basis, there's a big chance of my data getting compromised. Remember that brute force dictionary attack that I went through? Right? Now let me ask you this. If I wanted to, would I do the first tunnel manually? SHA and HMAC, there's no difference. SHA, HMAC is the variant of SHA that Cisco uses. There's no difference. It's basically the same thing. My question to you guys is, do I need to do this? What was the purpose of this? Set the session key. Why did I set the session key? So I have a dynamic key. So my data does not get compromised, right? My question to you guys is, can I set that session key manually, like a pre-shared key for data? If I do, I don't need this. You get my point? If I'm doing my session key manually, actually, I don't need this. I can just get rid of this. I can start my IPSec tunnel right over here. But then that would mean that I would need to set my session key manually. I'll show you that as well. We won't do it. Nobody does it today because it's not a secure way of doing it. But I'll show you how you would accomplish that. No, that's not aggressive mode. Aggressive mode, again, works with phase one. It's a faster way of doing phase one. So aggressive mode and phase one go hand in hand. Not just scalability issues, Sinat, it is also security issues. Why? If I don't do the session key, then I need to change the key manually. I need to have somebody sit down and change my session key every 1 hour, which is not possible. It's not viable, right? So if you're not doing that, it will be an issue. Good so far? You guys are okay with these so far over here? Right? Thank you. Let's call it T-set. That's just a name that I call my transform set because I need to call it later on. Now, I've done my 2 tunnels. This is my internet. This is my router. I have an internal segment. Okay. This router also happens to have another network. My objective over here is to encrypt traffic from where? Let's say 10.1 to 10.2. I don't want to encrypt. I don't want 192.168.1.0 to go to 2 or anyone. My whole objective of setting this tunnel up that I want to set up between what? These 2 guys is to encrypt this traffic going to there and vice versa. Or right now, yeah, point-to-point only. IPSec, the way we're doing it right now is point-to-point. But more than point-to-point from one network to the other. I could have done this, that would still be point-to-point, but more traffic that needs to be encrypted. But my objective over here is not to do that. My objective over here is to encrypt what? Traffic from 10.1 to 10.2. So I need to define that traffic. My traffic that needs to be encrypted. You get my point? So the third step over here in my configuration would be to configure the traffic that needs to be encrypted. People call it the interesting traffic, crypto traffic, basically the same thing. Bottom line, this is the traffic that needs to be encrypted. This is defined by using a normal extended ACL. Access-list, say 101, permit. I'm going to use this topology over here in which my internal traffic over here, let's say, is 10.4.4.0, and I'm going to be encrypting towards 10.5.5.0. So my encryption is from 10.4 to 10.5. My public address is 192.1.40.4. 192.1.50.5 is the public address of R5. Okay? The encryption that I want to do, the traffic that I want to encrypt is from 10.4 to 10.5. So I will say permit IP 10.4.4.0. This is my interesting traffic. Good so far, guys? You will see the messages, but you won't see the actual key. If that's what you're looking at. You'll see the exchange happening. So you guys are okay with these three steps that I showed you over here? Again, to recap, the purpose of the first step. Set my first tunnel up. Phase one, what's the protocol that sets it up? It's a protocol by the name of UDP. It uses UDP port 500. That's this. The second one over here. Before I go on to that one, what is exchanged over here? Session key. Key, encryption, hash. Key, encryption, hash. This is the session key that is generated by your Diffie-Hellman and exchanged. Second parameter, or second tunnel, sorry. I have the session key from here. This is phase two. Done by ESP. ESP is its own protocol. It's not a port number, it's its own protocol. Protocol number 50. Session key done. What else do I need for this tunnel? As I said, any tunnel needs a key, encryption, and hash. Encryption and hash. This is done based on your transform set. Agreed? And what goes over here? Actual data. Good so far. And what data will be encrypted? Where did I specify that? But if you notice, these three steps that I have are independent steps. There's no, where did I say this transform set should be used for this traffic or this is my phase one? Did I link them anywhere? Now we need to bring them together. At this point, I've created three independent entities. I need to bring them together, and that is done in my fourth step, which is called, which basically I'm going to give you a description of it. Link the above parameters to each other in a crypto map. The purpose of a crypto map is to bring all these above parameters into one place. All right, how do I do that? Crypto map, give it a name, whatever you want to call it. I'll call it CMAP, crypto map. Sequence number, let's say 10, because I can have multiple crypto maps. I'll explain that to you as well. Just pick that number for it as is. It can be any number, it's like a sequence number. Now, do you guys remember what I told you, that you have the ability to create your session key manually? Did I say that? If I do my session key manually, what did I tell you happens to this? I don't need it. Okay? I also told you it's not something that you would want to do, but if you did want to do it, just for the heck of it, you would not need phase one. Here, what you would say is IPSec manual. When you say IPSec manual over here, it's basically telling the crypto map, hey, listen, you're not going to have phase one. You're going to do your session key right over here. So there's a command over here called set session key. You're going to do one for inbound and one for outbound, and specify the key over here. This is how you do your session key manually. If you have to do it. Again, nobody is going to do it. That's why all the time, what are you going to see over here? IPSec ISACamp. What does ISACamp mean? Hey, listen, go get your session key from where? ISACamp. Inbound means the key that will be used by them to encrypt towards you. So this is, so when you say set session key inbound, that's your decryption key. The outbound is your encryption key towards them. But again, that's something that you would generally not do because, as I said, it is not the secure way of doing it. So I say, what? IPSec, ISACamp. For what peer? Who's my peer? Set peer. Now that I know my address, I'm going to do that. Let's say I'm doing this on R4. I'll say 50.5, public address of my peer. Good so far? And that same address I need to set up over here. So when I do IPSec ISACamp, it says my peer that I want to set this tunnel for is 50.5, this guy. But for what traffic? Actually, the first thing that gets checked over here is not the set peer, it's the match address 101. Basically says when the traffic comes in, does it match 101? 10.4 to 10.5? Oh yeah, it does match it. Let me set a tunnel towards what? 50.5. That's where it goes to this guy. So when traffic comes in on the interface, it sees that it matches ACL 101, which is 10.4 to 10.5. It will match it. It says, okay, yeah, this traffic needs to be encrypted to whom? To this peer. And that's where it goes to ISACamp to set my first tunnel up. Now, if the tunnel's already up, I don't need to set it up. I already have my session key. So the first packet will have this tunnel come up, exchange the session key. Once the session key is established, I'm now ready for what? My second tunnel. But all I have is my session key. What else do I need? My encryption and my hash for my second tunnel, which is defined in my, this guy over here. So that's where I'm going to call my transform set in my crypto map. Basically, that would be my phase 2 parameter. And I'm done. But the thing is, where do we connect ACL and ISACamp? Defined in part 1. When the traffic comes in over here, it matches this. These 3 parameters are together under the same crypto map. Sequence number 10. So when this traffic comes in, set a tunnel up based on ISACamp to this peer. So it goes and calls this up. You get that? Vinod? Oh, policy 5, I can have multiple policies. So what I'm going to do is, as the initiator of the tunnel, I'm going to send all my policies to the other guy. So if I had another policy over here with different parameters, I'm going to send all my policies to the other guy. I know who my peer is. So the peer is always this. The policies, if I have 4 or 5 policies, I'm going to send him all of them. He will pick the one that matches it. So it doesn't need to be an exact match. The other side can have 4 or 5 policies. I can have 4 or 5 policies. The number 5 is the first policy I'm going to send. So the smaller the number, more policy, first policy it'll check. For example, I could have this, just for the heck of it. So now what happens is, when the packet comes in over here, it matches ACL this guy because of this. Says, oh, I need to set up a tunnel, phase 1 tunnel using IPSec because of this IPSec over here towards whom? 50.5. So what key encryption and hash do I set up? I have 2 policies. I'm going to send both policies to the other side. He will have to match any one of them, this one or that one. The number 5 basically means I'm going to check, he's going to check that first. That's like a priority. But the IP address over here, there's only one key that matches, right? So this number is insignificant, it's more like a priority number, like a sequence number. Let's get rid of this for right now. The last thing though over here is I need to apply it. Apply the crypto map to the outgoing interface. So in my case, my outgoing interface, if you take a look at it, is E00. It's not clear over here, so I'll just put it. Would policies with the same parameters but different sequence numbers match? Absolutely. The number is insignificant. So I send the policy to the other side. As long as the parameters match, it's okay. Good so far, guys? So I'm going to apply this to the outgoing interface E00. Interface E00, the way I apply it, done. This would allow me to set up a LAN-to-LAN tunnel from where? From router 4 to router 5 to encrypt traffic from 10.4 to 10.5. You guys ready to paste it? Let's go ahead and do that. I'm going to jump onto router 4 over here. Looks like it took. Everybody okay with this? Now, what do I do on the other side? The reason I do it in Notepad, besides it being your notes, it allows me the ability to do second site much easier. So on the second site, which is router 5 in my case, what do I need to do? Let me give it a title as well. IPSec LAN to LAN VPN. So this guy can remain the same. I would need to change what? The peer IP to 40.4, which is the IP address of the other side. This can remain the same. The ACL will flip. right? This one again, and apply it. And go paste it. Boom. Is the tunnel up? You guys remember the show commands that you're talking about? The tunnel does not come up unless you have some traffic that gets initiated that will use the tunnel. So if you want to check your first tunnel, show crypto IPSec SA. SA stands for Security Association. Right now, there's nothing there. There's no tunnel that has been set up. Why? No traffic. As soon as traffic comes in, it'll bring the tunnel up. Once it comes up, the tunnel will stay up for 1 hour. Okay? So how do I bring it up? Generate interesting traffic. So I'll say ping 10.4.4.4, source 10.5.5.5. I'm pinging from R5. I'm pinging R4. Now, just to show you, if you look at your topology over here, I'm going from R5 to what? R4, there's R3 in the middle. The internet. What does the internet router have? Let me make sure that I don't have any routing for the 10 networks. Show IP route. I have a static route for 192.1.20. I have the 30 network. I have the 40 network. I have the 50 network. No routing for 10. So he does not know about 10. Well, what I'm going to do is, because of the encryption, it is going to do what with the packet? It's going to encapsulate the packet. So as soon as this traffic comes in, 10.5, going towards 10.4, it's going to hit this interface. On the interface, you have the CMAP. CMAP says check the ACL. ACL will match. Says, okay, set up a tunnel. Sets a tunnel up to whom? 40.4. So the outgoing interface is this guy. So I'll say, I'll create a packet from 50.5, 40.4. This portion over here, along with the actual data, will be treated as data and will be encrypted. So what you see on the internet is just this portion. Good so far, guys? Crypto IPSec enable on the router is enabled by default, Dinesh. So it is required, but they're doing it for you. Just like IP routing is done on a router. Is IP routing required on a router? Absolutely is. To make a router into a router, the command is IP routing, but it's enabled by default. Same thing with crypto IPSec enabled. It is required to be enabled, but it is enabled by default. Press enter. The first packet is lost because that was lost because of what? The tunnel trying to come up, exchange of the packets, setting up the phase 1. The rest of the packets were okay. The negotiation, right? Now everything's going fine. If you want to check now, show crypto IPSec SA. It's up. Correct. But that will give you a whole bunch of other garbage as well. Now, idle is a good thing. Why is it idle? What phase is this? What phase is this guy over here? Phase 1, right? What did I tell you about phase 1? What's the job of phase 1? Exchange the session key. Oh, and once the exchange is done, I'm going to sleep. So I'm going to stay in idle for how long? For the next 3,600 seconds. Then I'll wake up, exchange the key, go back to sleep. So most of the time, this guy will be sleeping. So idle is a good sign. You get my point? So where do I see the second tunnel? Show crypto, IPSec, SA. This shows you that this is the security association for what? 10.5 going to 10.4. It was set up based on port 500. That's UDP 500, IPSec. 14 packets have been encrypted and decrypted at this point. This is the inbound key that was used. This is just the key ID. I'm using the transform set with ESP triple des, ESP SHA. And this key will be up for another 3,506 seconds, which is roughly around an hour. All right. If I do it again, it will be over here. Both. It's in hex as well as in decimal. This is your decimal value. This is your hex value. What is the difference between quick and aggressive mode? Wrong comparison. You might want to compare the main mode and aggressive mode. You guys are okay with this? I'll explain that as well. And I'll also get to the NAT question as well. Everybody okay with this? Yeah? So you guys are okay with setting up a basic LAN to LAN tunnel between two devices. You understand every command over here. This is what was required. Every SPI will be different. Every session key will have a different session ID. It's like the key ID. Every key ID will be different. By the way, if you want to see that, I'll just do it. I'm not going to actually configure it, but crypto map ABC10, for example. SPI is the key session key number, like the index number for your session key. See this? Nobody does it, but understand what it does so that you understand that you do have the ability to skip phase one completely. If you do this, you're going to skip phase one completely because your session key now you're doing it manually. This is your get VPN. We'll talk about that. This is the most common one that you'll see. All right. Now the questions before I go through. That is correct. You have one set of IPSec phase 2 tunnel per ACL entry. Correct. You have a separate SPI, separate session key for every flow. That is correct. So you'll have a separate SPI, the session key, a separate session key for every flow. Now, the other questions that you guys asked are more under the hood type of thing. NAT, I will show you, but in phase one, there are two different ways of doing it. In phase one, you have a mode known as the main mode. In main mode, it actually sends its parameters, authenticates the other guy, then it starts doing the communication of what? Exchanging what? The session key and all the parameters. So the first thing it does, it verifies the identity of what? Of the peer before it starts sending its parameters to the other guy. This is called the main mode. In this mode, you have 6 packets that get exchanged. Okay? There's another way of doing it, which generally nobody will do because it's not safe. It's called the aggressive mode. In aggressive mode, I will send all my parameters before I authenticate the other guy. By doing that, I cut down the number of packets. I cut it down to 3 packets. This not recommended. This is like you're doing IPSec manual. So most of the time you're going to do main mode. Now what is quick mode? Quick mode is not for these two. Quick mode is actually for your phase 2. So in phase 2, I'm using quick mode, which is 3 packets in quick mode. Once I've authenticated it, I do quick mode in phase 2. But that's why I said, whoever asked that question about main mode, aggressive mode, you can compare it to what? Sorry, aggressive mode, you compare it to main mode because they both are for what? Phase 1. But again, I would highly recommend staying away from it. That is correct. You either have quick mode or you can, what do you call it? You can either do a quick mode or you can do GDOI, which is get VPN. I'll also show you that. But that's not basic LAN to LAN. That's something different. SPI is this, it's not the actual session key, it's the number of the session key. So you don't see the actual session key, but the number that you see over there is the ID for the session key. So it's telling you that this is the ID for the session key. You get my point? So don't think that number over there that you see is the session key. Good. The other question was about NAT. When would I do NAT? See, right now, the tunnel that I set up, my router over here, my router 4, was on the internet. This was a public address. Agreed? Quick mode is not risky because at that point, I've already established quick mode comes in phase 2. Phase 2 comes in after my phase 1 has already validated my peer. So both sides over here, I have what? Public addresses, correct? Now over here, let's say, and I am going to do that in a bit, I want to set up a tunnel from here to this guy. Can I do a tunnel to this guy over here? 10.11. This is my end. I have 10.1.1.0 over here. I want to encrypt from 10.5 to 10.1. And I set up a tunnel from 192.1.50.5 towards 10.11.11.0. If this is my internet, I can. So what do I need to do over here? I need to NAT it. I will do that for you guys. I'll show you that. Whoever that question was, that's the answer for that. So don't worry about the NAT portion. We'll actually do that over here. Good so far? So, you just done this part. But this is a foundation that will help you for all the different type of VPNs, because any IPSec VPN that you do, you will have phase 1, a lecture that I gave for phase 1 and phase 2. It will remain the same for all the different type of VPNs. That's why I spend so much time on it, because this is the foundation of IPSec. This is what IPSec is built upon. So whatever I do from this point on, you'll understand the phase 1 is to do what? Exchange your session key. This is your data. That remains the same on all of them. Clear? Good time to take a break. So this is basically the way the class is going to be conducted. So I am going to explain the technologies to you guys. I'm actually going to show you the commands and actually implement each one of those things that you see on this, list over here. And at the end of the class, the notes that I've been taking over here, like these, I'm going to send this to Katie and you guys can get it off of her. Let me save this real quick. All right, so it is roughly around 11:10 right now. Let's take a 15-minute break. based on this clock. Oops, not this one. Chai break. Yeah, absolutely, man. No coffee. It's night. I need to stay up. All right, guys, take a break. Be back in 15. I'll show you the NAT and the running of the VPN through the firewall. Hey guys, ready? Everybody back? All right, so let's go ahead and take a look at this over here, the same diagram, but now I'm going to do a different tunnel. Right now, what we did was we set up a tunnel from 10.4 to 10.5. The tunnel was set up like this. Agreed? Now I want to set up another tunnel over here from R2. Again, it does have a public address behind R4. So think about it being like your DMZ. This is, I'm going to make it into a firewall type. Put an ACL. I don't want to go too much into the firewall part. To set up a VPN now from R2, let's say to R5 over there. My second objective. So let's put a local segment over here. Okay. Now I want to set up a tunnel from R2 to R5. But before I do that tunnel, I want to make router 6 in such a way that no traffic is allowed from out to in. It's going to block all the traffic from out to in. The reason I want to do that is I want to show you guys how would an IPSec tunnel be established if you have a firewall in the middle. All right. So what I'm going to do on R6, the outside interface that you have, show run E0/0 30.6. I'm going to put an ACL over here. I have an ACL that I created. I haven't applied it yet. It's called FW. So on this outside interface, I'm going to apply an ACL that is deny IP any. Inbound. So what I have over here is an ACL called FW, which has what? Deny any inbound. Good so far, guys? And my objective is to set up a tunnel between what? R2 to R5 to encrypt traffic from 10.2 to 10.5. I'll show you two things over here. My objective over here is to show you two things. Number one is how do you set up a IPSec tunnel through the firewall? Number two, how do you set up two tunnels on same interface on router 5? All right, let's start with router 2 over here. I want to set up a tunnel from R2 to R5. Help me out, set that up. So this was which one? LAN to LAN, R4 to R5. Good. Now, IPSec LAN to LAN through the firewall. R2 to R5. Come on, guys, help me out with this. What should I do on R2? What are the steps to set up an IPSec LAN to LAN tunnel on R2? Phase 1. Which tunnel is this? What are the parameters that are required in the phase 1 tunnel, guys? Come on. Crypto, ISACAM policy 10. Authentication is pre-share. .5. And I have my hash. Let's use hash as MD5. We'll use group 5, keep it different. And my encryption, I'll keep it the same. Good so far? Lifetime, if I don't specify it for phase 1, it is a default of 86,400 seconds. Number 2, phase 2, which is it is called the IPSec tunnel, which is done based on ESP. Crypto, IPSec, transform set, reset, and this one, let's say also it uses MD5 HMAC. Good so far, guys? What's the next thing that I need to do? The next step. ACL. Clear? Step 4, crypto map. And last but not the least, apply it. Done? Let's check if it works. Copy it. Paste it onto router 2. Looks good. Now, router 5, I already have an IPSec tunnel over there, right? You guys see that? If these parameters that I have, let me just compare them. If these parameters, I'm going to put them side by side. Match the parameters that I already have. I don't need to create another policy. But they don't. Auth pre-share is there. Hash MD5 is there. Triple des is there. But my group is different. Okay. So what I'll do for R5, I'll copy these parameters. But over here, I have policy 5 already. So I'm going to create a policy 10, which will have these parameters. And I'm going to be pointing towards 20.2. Good so far, guys, with this? So on R5, I'm going to have two policies, 5 as well as 10. Which policies will R5 send towards R2? Both of them. And then R2 will match the one that matches one of its policies. As long as one of the policies matches, it's good. Clear so far? How about the transform set? Is it the same? Different. But I already have tset called it over here. So this one I'm going to call tset-2. So I'll again have two transform sets. If it was the same transform set, I could have used it, but it's different. You need to keep that in mind because I'm setting up two towns over here. How about the ACL? 101 is already used up, so I'm going to use 102 for this. And it is going to be from where? 10.5 to 10.2. Good so far. This is something that I'm going to be pasting onto R5. That's why I have R5 open. Now, this is where it gets tricky. On one interface, I can only have one crypto map. On one interface, I can only have one crypto map. Okay? Is R2 ACL correct? 10.2 to 10.5, yeah. What do you see wrong in there? This is the reverse, 10.5 to 10.2. Now, I'll do that, 1 second. So on one interface, I can only have one crypto map. And that is already applied over here because of the town from R5 to R4. So this crypto map is already there. So I cannot create a different crypto map, but in the same crypto map, I can set up a separate sequence number. For the same crypto map, I'm going to create a separate sequence number, which will have an ACL of 102. So this traffic, set the tunnel up to 20.2, and the transform set is tset2. I don't need to reapply it because it's already applied. Good so far? Can I paste it? Let's check. Copy it. It's supposed to be clear as mud. No, you don't need to reapply it, no. When the traffic comes in, the crypto map will be checked. Everybody okay with this so far? Now, if I look at my configuration on my router, take a look. I have two policies, two keys for different IP addresses, two transform sets, one crypto map with what? Two sequence numbers pointing to different IPs, different set pairs, different transform sets. If the transform set matches, would I have used the same transform set in both places? Absolutely. I had to use two because they did not match. Good. And on my interface, I will only have one crypto map. This tunnel will not come up. Why not? You guys remember I have an ACL applied where? Think about this being your firewall. I have an ACL saying what? Deny everything, inbound. Now the reason I did that is I want you guys to understand when I'm setting a crypto map up through the firewall, what are the entries that are required to be opened up on this firewall in this ACL? How many phases do I have? phase 1, which is UDP 500, and I have phase 2. ESP. Schaffner, you're not going to have 4500 over here. I'll explain what 4500 is in my second tunnel. I'll do 4500 as well, but for right now, I need to do these two. Inbound. So let's go ahead and do that. I take a look at router 6 over here. IP access dash list, extended FW, sequence number 1. I'll say permit UDP host. It's from out to in, 50.5 towards what? 20.2. EQ 500. Sequence 2, permit UDP host 50.5 towards, or not UDP, ESP host 20.2. ESP does not require any port number, it's its own protocol. So now if I do show IP access dash list, you have sequence 1 and sequence 2. Good so far, guys? Yeah? Let's do a debug over here, debug crypto IPSec. I'll turn it on. I'll go to router 5, and I'll try to initiate traffic to 10.222 from 10.555. The tunnel came up. You will notice that there's matches on what? On both the links. His own protocol, nor it has its own transport protocol. Protocol number is an IP protocol number. So for example, TCP is a protocol that works on the IP layer. Basically on IP layer, you point to TCP as a protocol using protocol number 6. UDP works at the transport layer. At the IP layer, you point to it using protocol number 17. Similarly, ESP works at the same level layer. It's an IP layer protocol. It has a protocol number 50. So it's not like UDP and your IPSec works over here. So that's where the port number comes in. You get my point, Carl? So ESP is at the same level as, it's an IP protocol working at the IP layer, so you need a pointer towards it. So in essence, I could have said permit 50 over here, it still would work. So my tunnel is up, but I want you guys to go over here and take a look at something. Now, this is what I was trying to show you guys earlier on. Remember what I told you? It will send all its what? Parameters. It has group 5 and group 2. Remember those two policies? Both were sent. Somebody asked me that question earlier on. Remember I told you both will be sent? So it basically matches whichever one matches my side. Debug crypto IPSec. This guy. And this is telling you phase 1 is successfully done. That also somebody asked me earlier on, how do I know it's done? IPSec successfully installed. Good? Everybody okay with this? So what did you learn over here? Points to remember. If you have to configure multiple IPSec tunnels on the same router, you are only allowed one crypto map per interface. You need to have multiple sequence numbers within the same crypto map for each tunnel with the appropriate parameters. Good? Right? Number two, if you have a firewall in the traffic flow, you need to open entries for UDP 500 and ESP. Done? And that would be this guy. Any questions so far? This is good so far? Now, I want to do another tunnel. Just to draw it out, so for your own remembrance, I did one tunnel over here. I did another tunnel over here. And I'm going to do a third tunnel now down here. I want to do a tunnel from R1 to R5. Now, R1 also has a private network behind it that I want to encrypt towards what? R5. Okay? But R1's public address, or not public address, outside address over here is what? 10.11.11.0. It's not going to work. Why not? This is a private address, RFC 1918 address. Okay? So I need to NAT that. NAT it and give it a public address on the outside. Have I done that? I think I did. Let's just check. Show IP NAT translations. 20. Why did I give 20? Should be on the outside on 30, so that is wrong. Include IP NAT. Can we ping R2 to R5 private networks at the moment? Yes, we can. I just did the ping. I'll show you again. Let me fix this NAT. What is the NAT on? What is the IP over here? 10.10.10.1. Okay. IP NAT inside source static 10.10.10.1 is 30.1. So the address on the outside. Show IP NAT translations. 30.1 is 10.5. Can we ping R2 to R5 external IP? R2 to R5 external ping? No, because I have a firewall over here The firewall is only allowing ESPN UDP 500. Emeka, got it? But the tunnel is up because that's what I allowed. Ping will not work. For ping, I would need to allow the ping in that ACL on R6. Take a look at the ACL on R6. What does it show you? What's allowed? 5 to 2. ISACamp is allowed. And 50 to 20.2. We don't need reachability between external IP to set up the tunnel. Yeah, we do. And this, what is this? What do you mean by reachability? Do you think ping is reachability? See, 55 to 2 external, I am allowing for what? ISACamp and ESP to set the tunnel up. I don't need to ping it. ICMP is not allowed. Yeah, I could, but I don't need to. But privates, the ICMP from private of 10.2 to 10.2, 10.5 to 10.2, that is allowed because that is going to be on the inside of the header. See the ping over here, the packet looks like that. ICMP from 10.5 to 10.2, but on the outside, it looks like this. Oops. It's an ESP packet from 50.5 to 20.2. So, and this is what is allowing it, ESP 50.5 to 20.2. And the firewall only looks at this. This part of the packet is encrypted anyways. Got it? This should clear it up. It's easier to do it based on IP to IP. When you do it through ESP, then you also need to do it for UDP. So it's easier, you just do an IP to IP. That way you don't need to do multiple protocols, Daniel. So the first thing that I did, I translated 30.1. So now this guy's IP address is, it's not 10. This is wrong. I need to fix this for you guys. This is .10.10.10.0/24. Okay. Now 10.10.10.1 is now translated as 192.1.30.1 over here. Good. So now let's do a tunnel from R1 to R5 first. That is the easy one. We'll do this one over here again. So this is IPSec LAN to LAN through the firewall with NAT from R1 to R5. So this is R1. Let's say I want to use the same parameters that R2 used. I'm still pointing to the same guy. The same parameters. ACL, I want to do 10.1. Okay. Crypto map remains the same. Apply. Look at this from R1 to R5's perspective. Do you guys see any changes that I need to make, or this looks okay? This is a tunnel from R1 to R5 to encrypt 10.1 to 10.5. This is your network. If you want to take a look at your diagram as well. Okay. This is the best I could do. Okay. From R1 to R5, 10.1 to 10.5, Take a look at this and tell me if you're okay with the R1 parameters. Looks good. Phase 1, phase 2, ACL, the crypto map, because this is my first crypto map on R1, so it's okay. No conflicts. Put it on the interface, point it towards 50.5. So I'll just copy this. Go to router 1. Paste it. Now, I'll go and pull up R5 over here. Help me out with R5's config now, because I have the ability to cut it down over here. Do I need to do this on R5? Or this suffices? Is it new policy or is it existing? Take a look. Pre-share, MD5, group 5, triple des. Triple des, MD5, group 5, all the same. It exists. So I don't need this. Everybody okay with that? Understood? Delete. I do need the key though, and it's going to be for 30.1, which is the public address of what? R1. Good. This guy, do I need this? This tset2 is the same. So I can completely get rid of this. I can use tset2 in there. Interesting traffic, I'll call it 103 now. 10.5 to 10.1. Agreed? How about my crypto map? 30, 103, 30.1. Still tset2, because tset2 is the one that matches this guy. Understood? This would be good enough. Why? The other parameters I already have, and I'm utilizing the same parameters again. So on the same router, purposely I put 3 different tunnels so you guys can see that if it's different, I need to use a different policy or a different transform set. If it's the same, I can utilize the same one over again. So now I can copy this, go over here, and paste it. Let's just do a show run. 2 policies for 3 tunnels, 3 different pre-shared keys, 2 transform sets because there's a match, 1 crypto map with how many sequences? 3 different ones. I would have 3 ACLs, 1 apply over here, 1 crypto map, 1 apply. I would have 3 different ACLs. Good so far? Clear. Now, one of the things that you guys need to know about is the way a Cisco router works with NAT. You guys remember what I told you about hash? What's the purpose of hash? To make sure the data or the packet is not changed, correct? When I do NAT over here, is something changing? Yep. Possibility of the hash breaking? Yes. So what Cisco has done is, not because I did NAT over here, every time in IPSec in phase 1, they have a process known as NAT detection. So as soon as IPSec starts, it starts doing a process known as NAT detection to detect NAT. Okay, how does it do it? When it starts sending the packet from here to here, initial IPSec packet, it starts with what? UDP 500, right? Whether it comes from this guy or it comes from that guy, it doesn't matter. Whoever initiates it, it starts with UDP 500. In that initial packet, what it does, and both sides will do this, they'll send they start the packet with their own header. What's their own packet IP? So their own IP that R1 will send out, because his outside address is what? 10.10.10.1, destination is 50.5, right? This is your IPSec packet, phase 1. But inside the data portion, what it does, it gives a clue, says my address is 10.1.1.1, 10.10.10.1. Okay? When this packet goes over here, what does this guy do with 10.10.10.1? NATs it, right? So the packet that is sent to whom? To R5 looks like this, doesn't it? .30.1, because I changed it to 30.1. That's my translated address for 10.10.10.1. Right, Sanat? What does this guy do when he receives a packet? Who does he receive the packet from? 30.1. But inside the data, it says my address is 10.10.10.1. So what does R5 know? That R1 is getting translated. So R5 sends him a message. Dude, you are getting translated. Understood? This took place over here as well. But because there was no NAT, the internal address and the outside address remained the same. So in this case, when this channel was going across, this one remained the same. It had 20.2. Inside was also 20.2. So the NAT detection came out negative. Understood? So how do they, now they've detected that there's NAT going on, right? Guys, okay, pay attention. First thing, I want you guys to know that with the NAT, does it change the packet? Yes. Okay. If I change the IP of the packet, is Is that a possibility that will break the hash? Okay. So I know that hash will be broken if there's an IP address change, so NAT can be an issue. So what Cisco does, when it initiates the first packet for ISACAM, not first, but initial packets, it will start a process known as NAT detection to detect if there's any NAT going on. Understood so far? Why is it doing it? Because I want to find out if there's NAT going on. If NAT is happening, I can change it and fix it. But I need to know if NAT's going on or not. So my main objective right now is just to find out if NAT is going on or not. Regardless of there's NAT or not, I need to find out if there's NAT going on or not, right? I don't know if NAT's going on or not. So how do I do the NAT detection? I send a dummy packet in which I will say my IP address. When I start the packet, my IP address is what? 10.10.10.1, right? And I create this packet 10.10.10.1, send it to my peer because I'm initiating an IPSec tunnel. Good so far. Why am I doing it? Because I need to detect the NAT. Everybody, did you go home? Yeah? Now I send the packet to R6. R6 has NAT. What does he do? He will change this packet over here and put what address over here? The translated address. Forwards the packet to 50.5. He gets it. Who does he get the packet from? 30.1. When he opens the packet up, what does he see inside? My address is 10.10.10.1, but he's getting it from 30.1. So what does R5 know now? That R1 is getting translated. Agreed? Everybody understand that? Okay. Now, R5, when he finds that out, he will tell that to whom? R1, you are translated. Right? So the problem has been detected. Now the fix. The fix, what Cisco did was, and most of the other vendors as well, they said, oh, I'm getting translated. So what I'm going to do is I'm going to put the entire ESP packet along with its hash, along with the IPs and the data over here, and I'm going to create, including the hash. Even the hash is where? On this packet. Then what it does, it creates a dummy packet outside, dummy header, which is based on UDP port 4500 with 10.10.10.1 to whatever, 192.1.50.5. The main purpose over here now is the hash is not on this part of the packet. Hash is where? On the inside header. So even if this changes, is it going to break the hash? Nope. And that's the fix. By putting up another header over here, which even if it changes, it will not affect the hash. That packet now will be UDP 4500. Once these guys have agreed that there is matting going on, they are going to use this packet format automatically. Automatically, this thing is happening regardless of what or how you configure your IPsec. It will automatically happen if it detects NAT in the middle. So did the hash field move? No, it didn't move. See, this is your ESP header, right? This is the entire ESP packet. The entire ESP packet got encapsulated inside an outer header. You get my point? Yeah, absolutely. It definitely makes it bigger. That's the drawback. It's a bigger packet, but at least it works now. Absolutely, Chris. It's happening automatically. So why am I spending so much time on it? No, the initial packet was still what? UDP 500. But now the ESP is never going to be seen by the firewall in the middle. Because ESP now is where? Here. What does the firewall see now? 4,500. You still need 500 because the initial detection takes place on what? Initial detection takes place on 500, and then you need UDP 4,500. You don't need ESP because ESP is where? Inside. Do you get my point? You automatically will change. So if it's a bigger packet, it'll fragment it. More chances, absolutely, Chris. After detection, the packets will switch over to 4,500. That is correct. So now you guys tell me, what should my ACL look like? Did I copy this already to R5? Yeah, I did, I think so. Because I was going through the comparisons. No ESP, Ernest, because ESP is going to be inside, right? You need ESP for the first tunnel. All right. For my second tunnel, IP access dash list, extended FW, I'll say line number 3, permit UDP host 192.50.5 to host 30.1, EQ 500. That's the initial NAT detection packet. 4, permit UDP host to 30.1 for what? 4,500. This is all done in phase 1, way before phase 2. Even in phase 1, initial packets are going to be what? Initial packets are going to start with what? UDP 500. As soon as the detection takes place, I'm still in what? Phase 1. I'll flip over to what? 4,500. So by the time it gets to phase 2, it's already moved to what? 4,500. So I still need the 500 because the initial detection is 500. Good so far? So let's again analyze your ACL and make sure you understand it. Don't forget, these two are what? 50.5 to 20.2. That was the first one. And over there, I did need to open up what? UDP and ESP. Why? I knew that this guy was not getting translated. So me as the administrator, the network engineer needs to know these type of things. What I see a lot people do is they do this. They open up UDP 500 any, UDP 4500 any, and ESP any. It'll work. One way or the other, it'll work. You get my point? That's not proper though, is it? Especially on a CCIE exam, they look for these specific things. If you open up any 500, 4500 and ESP, everything will work. You'll get a 0 for that question. You open up an unnecessary entry in your firewall ACL. And this is happening automatically. You don't need to do anything different to do this. NAT detection process is automatic. So let's do this over here. Actually, let's do the debug down over here. Debug crypto. ISACamp. We shall go to R5. Ping 10.1.1.1. Source 1055. Tunnel is up. That means it's going good. Now, I want to show you something that will tell you that I am doing NAT-P over here. This is my first tunnel, which is, no, this is my third tunnel. This is towards whom? Current peer is what? 30.1. What port number do you see against it? 4500. Why 4500? Because initially, as I said, the initial packets were what? 500. Then what did I tell you ISACamp switches to? So the actual establishment is done based on 4500, hence the 4500 over here. Okay? If you compare this with the other ones, let me just keep on going. This is my other tunnel. This is to 20.2. Notice what port was used to set that up? 500, because there was no NAT detected between what? 5 and 2. You see that? So it's talking to you, it's letting you know what's happening. And if I go over here, you will notice some packets were sent through what? ISACamp 500, and then did what? Flip. Yeah, but if there's a firewall in the middle, you don't open it up, the tunnel will not come up. You mean IQ2? Oh, it's the same. And there was another question that I saw and I couldn't answer at that time because I was saying something. What version of iOS did this start with? 12.2. So at least about maybe 13, 14, 15 years ago. Long time ago. This has been there on your Cisco router since 12.2, which is about roughly around 14, 15 years ago. So this is there. I also had a debug on. It will tell you that NAT was done. I did too, man. I did too. 12 was like the stable one. So you were there at the time when you would do the redistribute OSPF without the keyword subnet, it would not tell you. About the same time, I got my CCNA in 96, Chris. Let me see, where's the NAT? It'll tell you that NAT detected or something. NAT found. You see that? But on Cisco firewall, the ACL is done using the inside IP because ACL happens before NAT. Yeah, that depends on the device that you do. Either way, you need to do the ACL, whether it's the outside address or the inside address. The port number is still going to be 500 and 4500. You guys see this? That's how it flips now to what? from 500 to 4,500. Somebody was asking for NAT earlier on. Good enough? And that is this guy over here. Questions, guys? But if NAT is done with the first packet, I said the initial packets are UDP 500 until it detects natting. Once it detects natting, then it moves to 4,500. The initial packets are 500. It's not the first packet, the initial packets. That's why I need to open up UDP 500. That's why I see the hit count on that. Yes, you do. I think this is a good point to stop. Tomorrow, we will take a look at this. This one, and if I get a chance, I'll also go into MGRE. But I wanted to set the foundation over here so you understand. Now that you see how IPSec phase 1, phase 2 works, it becomes a lot simpler and faster from this point on. I agree, Chris. A lot of my learning has been done on that rather than books, because sometimes, unless you actually see it, you don't really understand it properly. Local address in terms of what? The ISACAM? We'll do that tomorrow. If you want, we'll cover that tomorrow. You don't need to download anything. I will send this stuff to Katie. Katie will make it available through RouterGods. The diagram, the one that I'm showing you over here, I'm going to send her that, the notes and the outline. So all the stuff that I went through today, you'll get that uploaded, including the video. Thanks, guys. This diagram. Thanks, Chris. Send a message to Katie. She will let you know. Yeah, it'll be available today. Keep on joining, guys. You got a lot of good stuff coming up still. All right, guys, you take care. You guys have a good day. I'll see you guys tomorrow, same time. Hey, Mo, how you doing? Good, good seeing you again. See you guys tomorrow then. Yeah, as soon as it is done rendering, I'll send it to Katie. Good. Take care. Bye now.